Hi folks, so this is question 7. So it just gives a triangle here. So there's a cyclist cycling on a road. So the gradient of the road is given by BC over AC. So you know that BC is 9. So BC over AC. So BC is 9. That's just the distance from B to C. So then you have to figure out what AC is. So it's just using Pythagoras. So you know that 9 squared, well, it's going to be 20 squared minus 9 squared and then square root. So you just put it all in the calculator together if you want. But that's going to be root 4819. So that's the distance from A to C. So therefore we'll put that on the bottom. So root 4819. Now it asks us in the question to give it write it as a percentage. So at the minute it's just a ratio or as a fraction. So 30% multiply 9 over root 9 multiplied by 100, and you have to round it off. So when you round it off to the nearest percent, you get 13%. Right, so part B then, so we can see some triangles, so therefore we know it's going to be trigonometry. So Olga wants to measure the vertical distance of a hill. So point H. Yeah, so it's OH that we're trying to work out. So you can put an X there if you want for OH. So we know that this here anyway, if you do 88 plus 87 and then take it away from 180, that'll give you this one here. So it's going to be 5 when you work it out. So 5 degrees at that angle. So that's going to help us work out. What we need to work out really is if you have an angle here, so you need one of the sides, or you need one of the sides at least in the top right angle triangle, and therefore you can use SOHCAHTOA or sin cos tan to work out the x. So I can work out this side here by using the sine rule. So you're going to have to use sine rule here. So we'll call it y for the minute. So y over sine of the angle opposite, which is 87 here, has to be equal to, and then you just pick any other angle inside in the bottom triangle. So that would be 20 over sine of 5 degrees. So that's just using the sine rule. So look up the sine rule if you're not sure about that. So then y is equal to 20 over sine 5 multiplied by just moving over the sine 87. So therefore now you can work that bit out first on the calculator separately if you want, and then multiply by sine 87, or it should work if you just put it all in. So you should get 229.15977784. So that's just rounded off as well, so that's what you get in the calculator. So that's what y is. So you know y is that, so therefore you have an angle and you have a side in the top triangle there. So we can use SOHCAHTOA, so we can use sin cos tan. So if you look from the angle 17 in the diagram, x would be the opposite and y would be the adjacent, or when we know what they are. So it's going to be opposite and adjacent, so I'm going to use tan. So tan of the angle 17 is equal to opposite, which is x over the 229.15977784, and I'm just leaving it to that many decimal places. We want it to be as accurate as possible then when we're finding out x. So x is going to be equal, I'm going to move over that number on the bottom. And then multiply it by tan 17. So that will give me a final answer. And we'll get 70 meters. So it's rounded off as well because they wanted to round it to the nearest meter. Right, so on this graph for part C, so they're looking for A and B, so they're looking for, so you see that the graph just goes up and down and up and down. That the maximum is the same each time, the minimum, so probably a few ways of doing this. But if you just look at somewhere like 4 there, obviously the minimum is at 4. And then if you look at somewhere like 6, the maximum is at 6. Now you could use 2 for the maximum, or you could use 8 for the minimum either, but if you just use those, so to get them, we'll get the minimum first. There are ways of doing it, but I think the easiest way is just to sub in what it is. So V of 4, because the minimum is at 4, is equal to 2 minus 0.4 cos of pi over 2 times, and just put in the 4 for the t. And you'll get 1.6. And then for the max, so you'll just put in V of 6, so just put in a 6 instead of the t. So 2 minus 0.4 cos pi over 2 times 6, and we'll get 2.6 there. Or sorry, I mean 2.4 there. When you sub it in, so you can just put it in the calculator. Just make sure your calculator is in radians as well. So A is equal to 1.6, B is equal to 2.4. Right, so the next one we have to just explain a little bit. So we have to mention what V dash T is. So the word to use most of the time here is rate, or pretty much all the time. So it'll be, so if we were to get V dash T, so that's, if we were to differentiate it, it's going to give us a tangent basically on the curve somewhere. So at any point, so it's going to give us the rate at which she's taking in air or breathing out air. So so V dash T is the rate at which she is because it's breathing in, breathing out, but that's in the question. So taking in air or giving out air, so that's probably not the best English, but something like that when you rate in it. So if V that, then just mention about if it's less than 0 or greater than 0. So if it's less than 0, like if you have a negative for V dash T, then obviously the rate will be going down, so it'll be that type of a tangent where it's going down. So therefore she's breathing out here. And then the opposite is obviously the other way. So if it's greater than 0, she is breathing in air. Because that means she has air in her lungs, so she's getting more air in, so the curve is going up. Right. So part E then. So find the volume of air in her lungs half a second after T equals 0. So all we have to do is find v of 0.5 here, v of a half, so equals, so 2 minus 0.4 times cos of pi over 2 times 0.5. So that's 1.717. Right, so rate again then, so the word rate is important, so that always means we're going to be differentiating pretty much, unless it's in a different context. So we're going to, alright, so the function is there, so v of t is equal to 2 minus 0.4 cos of pi over 2 t. So we're just differentiating with respect to t, so v dash t is equal to, so 2 when it's differentiated is gone, so we're just going to be left with minus 0.4. Now the differential of cos is sin, so it'll be minus sin pi over 2t, and then we have to multiply by the differential of what's inside the brackets in here, because we have to use chain rule because it's trigonometry. So therefore the differential of pi over 2t would be pi over 2, because pi over 2 is just by t. So that's equal to, now minus minus will make, because minus 0.4 being multiplied by minus sin, so it'll just be, well, it'll be pi over 2, it'll be positive anyway, so it'll be pi over 2 times 0.4 times sin pi over 2t. And then it's okay, so it's half a second after, so still half a second after t is equal to 0. So now we're just going to sub in a half, or 0.5 in for t. So pi over 2, 0.4 sin pi over 2 times 0.5. And use calculator then, and we get 0.444. So that's the rate at, or so yeah, that's the rate at which the volume of air is increasing when it's half a second after 0. So it's when she kind of starts breathing in, I suppose. Yeah, so it'd be about there on the graph. That's the rate at which she's taking in air then. Right, so part F then, so this is the hardest part. So it's going to, they're asking us to work out a function, but the conditions are changed a little bit. So it's going to be similar, it's going to look at the graph anyway. So it's going to start here. She's going to breathe in first, and then breathe out, and breathe in, breathe out, and so on. So she breathes in fully. Volume of air in her lungs is 3.6 liters, and when she breathes out fully, the volume of air in her lungs is 1.3. So she breathes in and out twice as fast. So because she's in and out twice as fast, if you look back up at the other one here, and she breathed in and out in the other one, it took 4 seconds. So it took her 4 seconds to breathe in and out. That's called the period on the graph. So that's kind of one cycle of the graph. So it's up and down, and then it goes up and down again. That's another. So the period for this one then, because it's twice as fast, has to be 2, because it'll be, so this value here has to be 2, because if it took her 4 seconds and then she's twice as fast, it's only going to take her 2 seconds. So to get the period of a function, it's going to be 2 pi over c, and so we're looking for the c part in this new function now. That has to be equal to 2 because that's the period. So therefore, the 2's will cancel out there on both sides, so you can just move over to c. 2 pi. So therefore, c is equal to pi. So c is equal to pi. So we've worked out that much. Now I'm using this information here. So that's the period of a function. So you have to use that. Now you have to, so we've got what c. But really, it's the a and the b that we're looking for now. So if you think about on a standard graph of costs, so for just y is equal to cos theta, so just the general graph of cos, it goes between 1 and minus 1. Yeah, so it goes down, down, up, down, up. That's for the standard one. So here, it's going to change slightly. So you see that max is, or sorry, the volume of air when they're full is 3.6, when it's empty it's 1.3. So if I do 3.6 minus 1.3, I get 2.3, and then if I divide that by 2, it gives me 1.15. So that's how much that the graph will change by then. So on the new one then, it has to be between, there'll be 1.5, well, there'll be a difference of 2.5, so from, or sorry, 2.3, so from there to there is 2.3, so kind of half up, so it goes up 1.15 and down 1.15, if that makes sense. So the distance between between the max and the min on the graph is 2.3. So therefore that works out what the b is. So b is going to be 1.15, but it'll actually be minus 1.15, and the reason is because if you look at the two graphs, the standard one, it goes down first and then up, but in this one here, it actually goes up first and then down, so it's changed, so it's the opposite. So therefore that's going to make the b into a minus. So we already know that c is pi, we know that b is minus 1.15, so we just need to work out the a, the first bit of the function. So we can get what a is by looking at how much the graph is being up by. So if we kind of go back to the general one, if that's minus 1.15, I'll just put it that side, yeah, and if this is positive 1.15 here, so if the graph was going up and down here, and that's how much, that's what it, yeah, it's between 1.15 and minus 1.15, but it's not that, it's up here, it's up above, up here, so therefore it's how far it's being moved up by. So we have to think about how do we get from there to get, because that's the minimum to get up 1.3. So what's the difference between 1.3 and minus 1.15? So 1.3 minus 1.15, and that will give us 2.45. So that's how much you have to move it up by to get up to the mid. So that means that a then is 2.45. So that'll be the first part of the function then. So put all that together then, and we get E of t is equal to 2.45 minus 1.15. But what A, B, and C is of pi t. That's going to be our final answer. So that's a hard question. You need a good understanding of the cos graph and what each part of it represents, so what A actually represents, B and C, so understand period and range, and just have a good understanding of the cos graph. So I wouldn't expect that many students to get that fully right. So that's it for that question.